Hey guys, this is Hemant from Edureka. Today's session is going to be on machine learning algorithms. So without any further ado, let's move on to the agenda to understand what all will be covered in today's session. So we'll be following a top-down approach. We'll start from the basics and understand what is an algorithm and how it can be used in machine learning. After that, we'll understand what is machine learning exactly and how a problem can be solved using machine learning. After that, we'll be discussing various techniques using which a machine can learn. And after that, we'll also be discussing some of the basic algorithms which are used in machine learning. Towards the end, we'll be doing a demonstration wherein we'll see how we can prepare a dataset for the creation and validation of a model. And after that, we'll be creating a model using one of the algorithms that we'll be learning today. All right. So guys, this is our agenda for today. Are we clear with it? Okay, I'm getting confirmation. So Karan is clear. So is Suraj, Matthew. Alright guys, since most of you are clear, let's move on to the first topic of today's discussion, that is, what is an algorithm? So let's start this topic with a very generic approach. So if you were to interact with the computer and tell it how it should execute a particular task, the way you do it is using a program, right? So what is a program? A program is basically logic which is wrapped around a syntax, a particular syntax which is specific to a programming language. Now this programming language could be anything. It could be JavaScript, it could be Java, it could be Python, it could be C, it could be C++, whatever, right? But the basic thing doesn't change. That is the logic, all right? The logic remains the same in every language. Having said that, what is this logic? This logic is what an algorithm is. Alright, so in simple words, an algorithm is a step-by-step procedure towards solving a problem in the computer world. Alright, so let's take an example to understand this thing which we have just discussed. Alright, so let's take an example. So this is a problem, or this is an algorithm to print numbers from 1 to 20. Alright, so let's go step by step and understand what this algorithm is doing. So this is the start position. We start over here, and then we see that our algorithm is initializing a variable x to 0. All right, so we initialized a variable x to 0, and then we incremented it by 1. After that, we are printing that variable and we are checking it whether it's less than 20. So if it's less than 20, if it's true or if it's yes, it goes back and increments the value again by 1. Otherwise, if it's a no, it goes on and ends the program. All right. So since it's a yes right now, it goes back and increments the value by 1 again. So we have printed 1, and now we have incremented the value of x by 1 again. So now the value is 2, and then we print that value. So we have now 1 and 2 on the board. All right. Then again it checks whether it's less than 20. If it's true, it goes back again, increments it by 1. Now it's 3, prints 3. So this process goes on until the value of x reaches 20. So when the value of x is 20, it prints that value and it checks whether it's less than 20, which is a no, and then it ends the program. And hence you have values which are printed from 1 to 20. Alright, so this is a step-by-step procedure for printing values between 1 to 20, and this is in similar way you would create other algorithms as well. So as complex an algorithm can be, it can always be represented using a flowchart. Alright, so guys, this is what an algorithm is. Now our next topic is what is machine learning. Now for making a machine learn, there are a lot of ways and there are a lot of algorithms. Alright, now since no problem is the same, every problem, so if we take our case, alright, so we tackle every problem with a different approach. Now algorithms are nothing but approach for a computer. Alright, now based on the problem, you decide which algorithm to use. Right, so for now let's understand what is machine learning. So machine learning is basically an artificial intelligence wherein the machine can learn on its code, meaning you have programmed it once, but every time it encounters a problem, it should not be programmed again. That is the main motive of ours, right? It will not be programmed again. It changes its own code according to the new scenarios it discovers. All right, so this is what machine learning is. It self learns whatever has to be learned from it. We provide it scenarios, we provide it with past experiences, we feed the values, and learning from those past experiences, it comes up with new solutions. This topic is actually very interesting to learn about because you might be thinking how a machine can actually redo its code, or how can it update its code on its own, right? So sounds interesting, right? So this is what we'll be doing in the next few sessions, that is learn about machine learning. So today's session is going to be a very basic session. We'll be seeing how machine learning actually works, what is the basis for machine learning, all right? So by the end of the session, you'll have a fair idea of how things basically work with machine learning. But for the advanced part of machine learning, we have the next sessions lined up, so I don't want you guys to miss any of those sessions, all right? Okay, so moving ahead now. So we have learned what machine learning is, but like I said, there are different approaches towards solving a problem, right? So there are basically different ways a machine can learn. Let's see the different ways a machine can learn. Basically, there are three kinds of ways. So the first way is supervised learning. The second way is reinforcement learning. And then you have the unsupervised learning, all right? So let's discuss each of these in detail and understand what these actually are. So the first kind of learning is called supervised learning. All right. So what is supervised learning? So supervised, if you concentrate on the word supervised, supervised means when you are monitoring someone, or when you're constantly monitoring someone or making them understand something. So you can compare this scene with a classroom scene, all right? So you sit in a class and the teacher explains you difficult concepts, right? The concepts that cannot be learned on your own. That's why a teacher is there, right? So the way we teach machines in supervised learning is like this. So we provide them with a particular set of inputs, and we give the corresponding answers as well. For example, if I say that what are the parameters for deciding whether it will rain today or not? So the humidity should be above some certain level, temperature should be above some certain level, the wind should be in a certain direction, and then if these scenarios are there, it will rain, right? So we give a lot of inputs to the computer with this data, and with each data we assign 1 it rains and 0 it does not rain. If the temperature is high and the humidity is high and the wind is in a particular direction, it will rain, so we say 1. And if the humidity is low and the temperature is low as well, so we say it will not rain. So I'll give it a certain input that today it's 35 degrees Celsius, the humidity is 97%, the wind is in this direction, will it rain today? All right. So the machine will actually see, okay, so from my past experiences, I saw that, okay, when this was the temperature and the humidity was this, it rained. So it'll compare that according to it, and it'll come up with a probability and hence come up with a solution or an answer whether it will rain or not, right? So this is what supervised learning is. So basically, we are providing it with the answer and the inputs as well. All right. So if you were to discuss it in a more general way, so you can take your kids as an example. So like I said, your kids go to school, right? So your teacher is explaining concepts to your kid using examples. So you tell them, so if you're trying to make them understand something, you're giving them examples, as in this is the way it happens, right? And that's what we do as well. We, in supervised learning, we give the machines example. So example, that day it rained and the scene was like this, the temperature was this, the humidity was this, and hence it rained, right? So if the inputs are like these, you come up with a decision, okay, it will rain, right? So this is what supervised learning is. Our next topic is unsupervised learning. So basically, if you understood what is supervised learning, so okay, so first, guys, any doubt in what supervised learning is? Okay, Suraj says it's clear. Others? All right, cool. So our next topic is now unsupervised learning. So what is unsupervised learning? So you can understand unsupervised learning by comparing it straight away with supervised learning, all right? So in supervised learning, like I said, you were giving them answers as well to inputs. But in unsupervised learning, you don't do that. You just give them inputs. Now, you are not telling your computer what will be the answer. So what computer does is, or if you think logically, the only thing the computer can do with the inputs is find a pattern behind it or find a structure in it, right? So this is what the computer actually does. So in unsupervised learning, what it does is you provided inputs, right? So for example, I want my computer to, I give my computer some inputs on fruit, Right? So I don't tell the computer what the fruit is actually, but I give other parameters such as how big it is or what color it has. Say, what is the taste of that fruit? All right. So when I give all these conditions or all these parameters to my computer, so it groups the fruits based on that. So basically, it will group it on the basis of size. It will group it on the basis of taste. It will group it on the basis of color, right? And then it shows us that data, and then we can actually label. So okay, so if the size is big and the color is this, this fruit will be known as an apple. All right, now what kind of problems are actually there in unsupervised learning could be when we don't know whether there is a correlation in the data or whether there's a structure in the data. For example, if we talk about big data, right? So big data is nothing but a huge chunk of data, right? So we don't know that data is random. It's not structured. Right? So whenever we want to find a structure in data, we use unsupervised learning. Now it's the job of the algorithm to figure out if there's a pattern in the data. And if at all there's a pattern, it gives us that pattern. And hence we can decide how we can move ahead. All right. So if we have structure, or if we know how that data can be differentiated, how it can be structured, then supervised learning can be applied on it. But if we don't know what that data structure is, we use unsupervised learning. All right. So guys, are we clear with what supervised learning is and what unsupervised learning is? Okay, so if you were to take the same example forward, so we talked about your kids in the previous example. So in the previous example, that is supervised learning, your kids were learning in school, right? So your teacher were telling them examples and were teaching them how what a particular problem is and how it can be tackled. But unsupervised learning is when your kids are learning on their own. So they have their books, right? So they're trying to figure out what a thing is on their own. So that is what unsupervised learning is. Moving on to the third part, which is reinforcement learning. So what is reinforcement learning? So reinforcement learning basically is when your computer is trying to take decisions, all right? So what kind of problems can we include in reinforcement learning is say when you wanted to teach your computer how to play chess. Now you cannot tell your computer what to do because there are a lot of things, there are like a zillion possibilities or a zillion moves that can be done in chess. So you cannot tell each and every move to your computer. But what you can tell is whether he did right or wrong. All right, and that is what reinforcement learning is. For another example that you can take is when you're training your dog. All right, so you cannot tell your dog what to do because he will not understand. But you can actually reward your dog if he does right, and you can punish him if he does wrong. Right, so that same thing is actually applied in reinforcement learning as well. So it basically, the computer's aim is to maximize rewards, right, when it does actions. So it'll come up with a solution which has the maximum rewards in place. So we define if it does a certain action, you'll get a reward. And then from its past experiences, it understands, okay, when I did this, I got a reward. So let me do something similar, I'll get more rewards, right? And that is what reinforcement learning is all about. So if you were to take the same example forward, let's say your kid, when you're parenting your kid, you tell him, you cannot control what your kid does throughout the day, right? You cannot tell him each and everything. But if he does a bad thing, you can actually scold him and tell him that what he did was wrong. And then he'll understand, okay, I don't have to do this thing because I get scoldings when I do this thing, right? Or else you can appreciate your kid when he does a good thing, right? So he'll understand, okay, I was appreciated for this, so maybe this is the behavior which is expected from me. So this is what reinforcement learning is, right? So guys, are we clear with what supervised, unsupervised, and reinforcement learning is? Any doubts in any of these three learning techniques which are there in machine learning? Okay, I've got a question from Anita. So Anita is asking me, can you give me one more example for reinforcement learning? Okay. Okay, so consider this. So you have a temperature control system at your home, right? Now that temperature control system has to decide whether I should lower the temperature or I should increase it. All right. So this is an application which actually uses reinforcement learning because it has to make a decision now. So whenever there's a decision that has to be made, you use reinforcement learning. Now, how will it decide whether it will increase the temperature or decrease the temperature? It will decide based on its past experiences. right? So it will see what is basically the user, or how a user responds to a certain temperature, right? And then it will come up with a decision. Okay, so if my temperature is 32 right now, maybe I need to lower it down. Maybe I need to lower it down to 30, right? So this is just an example. There are a lot of parameters that are taking place, how many people are there in the room and everything, but then this is how the algorithm works when it takes decision based on its past experiences. Right, so if you go by the definition, so reinforcement learning was actually inspired by the human behavior or the rat behavior when it is there in the maze. Right, so when a rat is there in a maze, it has to decide whether it should stop, it should go left or right. Right, so that is what this algorithm has been inspired from. Any more doubts, guys? Any more doubts in supervised, unsupervised, and reinforcement learning? Okay, so I've got confirmation from the most of you. Since most of you are clear, let's move on to the next topic. We now know what are the different ways a machine can learn, right? Now let's discuss how you actually can solve a problem using machine learning. All right, so now a problem comes up to you. Now how will you decide, or how will you start with that problem? So let's shed a light on that. So whenever there's a problem, that problem can be categorized in 5 ways. So those 5 ways are like this. Is this A or B? Is this weird? How much or how many? How is this organized, and what should I do next? So your problem would want an answer which could be, is this A or B? As in you have a problem which is asking, say you are differentiating between fruits. Is this an apple or is this a banana? All right, so when you have these kind of problems, you use classification algorithms. The next category is this weird? Analyze patterns. All right, so when you have problem wherein you have to analyze pattern, wherein you have to find an anomaly or an odd one out, you actually go for anomaly detection algorithms. All right, the next category is how much or how many. So when you have to deal with numbers, right? So when you want some numeric values, you want to get a certain value, or for example, what should be the minimum number of hours that you should put in so that you get promotion. All right, so when you have these kind of problems, so you apply regression algorithms onto that. Then we have, how is this organized? All right, so when you have these kind of questions, you use clustering algorithms, because basically you're trying to find out what is the structure behind a certain data set, right? So when you're trying to know the structure behind a certain problem, you use clustering algorithms. And then you have a category which says, what should I do next? So when a decision has to be made, then algorithms for reinforcement learning are used. All right, so guys, any doubts in any of these 5 categories that we have just discussed? So basically what I'm trying to tell you is that each question, so any kind of problem that you come up with, can be categorized under these 5 categories. All right, it cannot be beyond these 5 categories. It will definitely come up in these 5 categories, and then you can relate to a category and then come up with an algorithm. So when you have a set number of outputs, you use classification algorithms. All right, so it works like that. So any doubt in whatever we have discussed so far? Okay guys, since most of you are now clear, alright, so let's move on to the next topic. So we've discussed, so when we have these kind of problems, we come up, we can solve this using these algorithms, right? So let's learn about these algorithms now, that is classification, anomaly detection, regression, clustering, and reinforcement, as I said. So let's shed a light on that. So let's start with algorithms, machine learning algorithms. So the first algorithm is the classification algorithm. So like I said, when you have a set number of outputs, so basically for questions like this, so is it cold outside today? So it's, the answer could be either yes or no. So you have only 2 outputs. The outputs could be either yes, or the output could be no. All right, or the next kind of question could be, will you go to work today? So it's either a yes, no, or maybe. Right, so you will either go for work or you'll not go for work, or you'll say maybe I'll go to work, right? But there is no other answer which can come up, right? So when you have these kind of conditions, you come up with, you solve it using classification algorithms. Now, when you have two outputs, as in like, for example, yes or no, it is called two-class classification. But when you have more than two choices, as in our second question, we have yes, no, or maybe, right? So this is called multi-class classification. So whenever there's an output which is set, as in it is either true or false, or 0 or 1, or yes or no, whatever, right? So if it's fixed, you use classification algorithms. This is basically the gist that you should get out of this. Any doubt in whatever we have discussed? Okay, so let's move on to our second algorithm now, which is the anomaly detection algorithms. So in these algorithms, you analyze a certain pattern, and you get alerted whenever there's an anomaly or something which is not usual which happens. All right. For example, if, as you can see in the figure, that you have a pattern, you have some blue men, right, and then suddenly a red kind of person comes up. So this algorithm will actually flag that person because he breaks the pattern. He is something which is not expected, right? And he becomes an anomaly. And this is what anomaly detection algorithms are all about. Now, what is the use case for anomaly detection algorithms? It could be, for example, in credit card companies. So in credit card companies, each transaction of yours is monitored, right? And whenever there's a transaction which is not usual, right, which doesn't match your daily transaction pattern, you get alerted for it. So they might confirm with you whether you only made this transaction, right? So when you have these kind of problems, you use anomaly detection algorithms to solve them. The third algorithm is regression algorithm. So like I said, whenever you have to come up with a value, right? So you use regression algorithms. So for example, what will be the temperature for tomorrow, right? So whatever value will come out of this will be a number, right? So let's say I came up with 28 degrees Celsius. So I got that temperature using some formulas, right? And I came up with that numeric value. So whenever I am come up with a numeric kind of value, or whenever my problem demands that I have to get a mathematical value, I go with regression algorithms. So the second example for this could be whenever I want to give a discount to my customer. Now, how much discount should I give that customer so that I get more customers, and at the same time I do not go in loss as well, right? I stay in profit. So whenever this kind of problem comes up, I can go on and use a regression algorithm and solve this kind of problem. All right. Moving ahead, we have clustering algorithms. So clustering algorithms are basically used, so we discussed unsupervised learning, remember? So in unsupervised learning, we have clustering algorithms wherein we try to establish a structure, right? So we have some unstructured data that you want to make sense of. So what we'll do is we'll pass it through a clustering algorithm, and if there is a pattern which a computer can see, it comes up with that pattern and shows us like this. So for example, I feed data to my computer, right? And my data then applies clustering algorithm onto that. So this is the kind of output that I'll get. So it'll categorize it under group A, group B, and group C, and then I can make a decision whether what I want to do with this data that I've got. All right. So this computer doesn't understand anything, what this data is all about. It doesn't understand. Maybe it's of cars, maybe it's of food, maybe it's of money, right? So the computer doesn't understand. But what computer understands is numbers, right? And that is how it relates it to each another and comes up with groups. Now when it comes up with groups, maybe you want to use some other algorithm onto it and decide or come up with a solution. But this is what a clustering algorithm will give you, right? Having said that, let's move on to the next algorithm now, which is reinforcement algorithm. All right, so we discussed reinforcement learning, so that is what reinforcement algorithms are all about. Whenever you have to make a decision, right? And so whenever you have to make a decision and your decision is based on the past experiences of your machine or whatever inputs that you have given to your machine, you use reinforcement learning. Now, for example, whenever you wanted to train your computer how to play chess, it will use reinforcement learning. And when it has learned, or when you have created a model for that and your game is actually being played by the computer, each decision that the computer makes is also based or is also taken from reinforcement learning. The other example, like I told you, was of a temperature control system, wherein your system had to decide whether it should increase the temperature or it should decrease the temperature, right? So whenever these kind of problems are there, right, you use reinforcement learning or reinforcement algorithms. Okay guys, so this brings us to the end of machine learning algorithms. So we have basically covered the basics which are there. We have covered the basics of the algorithms which are used in machine learning. So now if I give you a problem, you should be able to identify which algorithm will fit into this problem, right? What each algorithm is all about, how many algorithms are there, we'll discuss that in our later class. But for now, for today, you should understand, if I have this problem, okay, so if I have this kind of problem, I should apply this algorithm to it. How will I apply this algorithm? We'll be discussing that in the later class. But this is the idea that you should get today. This is step one. If you are through with step one, it becomes very easy, because now just about learning about what each algorithm does. But this is the concept behind machine learning. This is the concept that should be set in your mind, that whenever this kind of problem comes up, okay, so I have to find a structure behind this problem. Okay, I'll use clustering algorithms. Okay, so I have solutions to this kind of problem. Okay, I'll use supervised learning, and I'll be using algorithms and supervised learning for this, right? So I have a fixed number of outputs for this. I'll use classification algorithm for that. All right. So this is the basic understanding that you should get from this session today. All right. So enough of theory, guys. So we have now understood the concept behind machine learning. Now let's see. First of all, you guys won't be knowing how the inputs are actually given to a system to create a model, right? So these inputs are actually called data sets, right? So now what we'll be doing is we'll be seeing how we can prepare a data set to actually create a model, and then also verifying that model, whether that model is predicting right or wrong, right? So let's take a sample data set. So basically what if we'll be doing our machine learning demonstrations in R. So I expect you guys to download R Studio and the R language in the next class, because the next class will also have a lot of demos. For today, you can just see how am I doing right now, and later you'll have the code in your LMS. You can use that code and execute it and like be ready in the next class, because in the next class it's going to be a lot of demo. Right? For today, our demonstration, what we're going to do is, so this is, guys, the input that you get. So these are the values. This is a data set which is called empty cars. It's a sample data set in R, right? So whenever you have to create a model, you basically divide your data set, because you have to validate that model at a later stage as well. So you divide your data set between the training part and the testing part. So the training part is used to create a model, and the testing part will be used to actually verify that model. All right. Now, how you can divide the data set is what I'm going to tell you in a few moments. But is this clear to you guys? Why are we dividing the data set? We are dividing the data set because first we will create a model. So for creating a model, the computer should be fed some value, right? So when it will be fed some values, it will make sense out of it, and it will come up with a model. Now this model can be used to predict values, right? But how will we verify whether it is predicting correct values or not? So for that we have the testing data set. So we'll be picking up some values from the testing data set, feeding in the values, and we'll see whether it is producing the correct output or not. All right, are we clear with our problem statement? All right guys, so let's begin our demonstration then. So this is your R console, guys. What you'll be doing is, first you'll write this command which says data empty cars. So what this basically will do is it will import the sample data set called empty cars. All right. So I've got a variable now which is empty cars. So let me show you this data set. So this is how my data is like. So basically these are the car names. So there are names of the car, and then there are some values associated with that car. For example, this is the displacement of the car, this is the weight of the car, and based on the weight and displacement and the horsepower and the other values, you have these two values, which is whether it has a V kind of engine or whether it has a straight engine. All right. So if it has a V engine, it will be a 1. If it has a straight engine, it will be a 0. All right. So some values might indicate that it can have a V engine as well as a straight engine as well. But with today, what we are going to do is we are going to predict. Basically, we'll be taking in two values. We'll be taking in WT, that is the weight of the car, and we'll be taking in DISP, that is the displacement of the car, and then we'll be predicting whether this car will have a V engine or a straight engine. So we'll be creating a model in the later part of today's demonstration. But for now, we have to divide this data set between the training data set and the testing data set. So let's see how will we do that. So first of all, we have to import a library called CA tools. All right. So we'll import that library. So it is set. All right. So now I will write split. I will define a variable called split, and then I will write sample.split, and now I will enter the data set, which is empty cars, and then I will specify the split ratio equal to, now I want my training data set to be 70% of that data set and my testing data set to be 30%. All right, so I'll specify 0.7, which specifies 70%. All right, so basically what I'm specifying here is that I want to split my data set empty cars into 70-30 ratio. All right, so let's run this command. All right, this command is run. All right, so now I will run this particular variable. I will execute this particular task. So it has now been executed. So what basically has now happened is it has picked out random values, right? And for each value it has assigned either a true or a false, right? So 70% of the data set has is true and 30% of the data set is false. Now we'll be leveraging that and we'll be deciding our training and testing data set based on that. So training data set is equal to subset of empty cars where split is equal to true. Alright, so basically what I've specified here is my training data set will be a subset of empty cars where the split is true, right? So my true is 70% of the data set, right? Remember? So now we'll be executing this. So I've executed it, and similarly for testing I'll specify that the split is false. Right, so I'll write false over here and then I will execute the statement. Alright, so let's check whether we have splitted our data set or not. So let's check the testing data set. So as you can actually see it from here that testing has around 12 observations and training has around 20 observations now. So the data set has been splitted. Our empty cars had 32 observations. We have split it in 70-30 ratio. So our training data set has now 20 observations that are 20 rows, and our testing data set has 12 observations. All right. So let me show you my testing data set now. So as you can see, this is my testing data set. This was the whole data set, that is this is the whole of empty cars, and this is the data set that has been divided now. So my testing data set is 30% of this and it has these many values. Alright, so now we have splitted our data set. Now let's now create a model. Alright, so the creation of the model is same for each and every algorithm, just the command changes. So let me apply a regression algorithm right now. It's called logistic regression. All right. So what logistic regression does is it comes up with a value, right? And with that value, you decide whether it will be a 1 or a 0. So my logistic regression, actually, you might ask a question to me that, okay, so this kind of problem, we have to decide it should be either 1 or a 0. So it's a classification problem. True, guys. But behind that classification, we are actually calculating probabilities, right? So we are actually coming up with a number, right? So if we are coming up with a number, we use regression algorithms. But when you talk about logistic regression actually comes under the classification algorithms as well and the regression algorithms as well. All right. So we'll be applying logistic regression, and the logistic regression will then give me a probability of as in when I give in the values WT, that is the weight of the car, and the displacement of the car, it will give me a probability whether this car will have a VS engine. What is the probability of this car having a VS engine, right? So this is the probability that I'll get, and this is the model that I'll be creating right now. So let me clear my console. Alright, so for creating a model you have to type command which is like this. So you just type in model. Alright, and for logistic regression the command is glm, and then you'll be giving the formula. So the formula is we have to predict VS, right? We have to predict what is the value of VS. Will it be a 1 or a 0? So we'll say VS tilt, this means versus WT plus DISP, right? So I want to take into account the weight of the car and the displacement of the car, and I want to predict when the weight of the car is WT and the displacement of the car is DISP, what will be the value of VS. This is the formula that I want my model to predict. Alright, now I'll be specifying which data set this model has to be applied on. So since I have splitted my data set, so I want it to be applied on training, and then I have to specify the family of the model. So basically it's a 1 or a 0, right? The values, the answer that the VS value is in 1 or 0, right? So the family is binomial. So this is what you will be specifying, right? So let's execute this particular statement now. We'll click on run. Alright, so my model has now been created. So let me show you the summary of the model now. Alright, so as you can see, I have came up with a model and it has given me some coefficient values which has been calculated. Now what are these coefficient values? Don't worry right now. I'll be explaining this in the next class. But for now, what you have to understand is, what I'm trying to make you guys understand is that we are coming up with numbers. Alright, so we are not doing any clustering, we're not doing any decision making. We're coming up with numbers, and that is the reason we use regression algorithm. Now further, as you will see in the next step, I will be predicting a value which will be the probability of the car having a VS engine. Alright, and then I will teach you how you can actually classify that problem as a 1 or 0. Alright, so hang on. So now what we'll be doing is we have a model, right, and this is our testing data set. So as you can see, these are the values that we are going to predict right now. So what we'll be doing now is we will actually be feeding the WT and the ISP of this testing data set. And mind you guys, our model has been created from the testing data set, all right? So from the training data set. So we have not, so our model has not encountered the testing data set as of now. So these are basically like real values to our model, right? So now we'll be predicting. So let's take an example car here. So let's take Ford Pantera L and predict whether this car will have a VS engine or a straight engine. All right. So let's feed in the values for that. So we'll be creating a data frame first. So we'll be feeding our values in the data variable, data.frame, and then the WT value is, so for Ford Pantera L, the WT value is 3.170. So let's feed in that. 0.170, and the DISP value is 351. So let's feed in that as well. So we have fed the values. Now let's predict it. So we'll be predicting our answer in this variable. So the command for predicting is predict model. That is the model that we have to predict from, the data which has the values, and the type of answer, that is response. So I want a response. Now what I'll be getting from this is a probability, right? The probability of this car having a VS engine. Now if the probability is less than 0.5, that means that the probability is that means that it will not have a VS engine. The odds of it having a VS engine becomes very less, and hence we will consider it as a false. But if it is greater than 0.5, that means the odds of having the car having VS engine becomes more, right? So we will consider that that car will have a VS engine if its probability value is greater than 0.5. So having said that, let's execute the statement and then let's print the answer. Ford Pantera L, we predicted that the VS probability, the probability of that car having VS engine is 0.007. Let's compare whether our Ford Pantera L has a VS engine. So as you can see, there is 0 over here. That means that Ford doesn't have a VS engine. So if it doesn't have a VS engine, it has a straight engine, and we have predicted it right. Our value is correct. Having said that, let's predict one more value for a car which has a VS kind of engine. So let's pick a car from here. Let's take this car, which is Toyota Corona. All right. So let's feed in values for Toyota Corona. So for Toyota Corona, our displacement is 120.1. So let us feed that 120.1, and my weight is 2.465. So let's feed in that as well. Let's predict the value now. So as you can see, the probability of Corona having a VS engine is 0.77. All right. So it has a 77% probability of it having a VS engine. Let's check whether it has a VS engine. So yes, it has a VS engine, and hence our model predicted the right value. All right, guys. So we created a model which can predict values now. So you can feed in any displacement and any weight, and this model will tell you whether that car should have a VS engine or a straight engine. Right? So this brings us to the end of our session, guys. So before that, do you have any doubts in the demo that we did right now? Any doubts, and I'll explain it right away. All right, so Anita has a question. She's asking me, she understands this is a regression algorithm, but why is it a classification algorithm also? Okay, so Anita, as I told you that regression algorithms basically compute values, all right? You are calculating probability here. But based on this probability, you are actually classifying. Okay, let me show you how this will happen. Just wait a second. Okay, Anita, so let me type in this for you. So if you type in this command and you specify that if it's greater than 0.5, specify it as true. All right. So I've just specified greater than 0.5, and then let's check what will be our answer right now. So it says true. So now you have specified that for this value, which was 77%, if it's greater than 0.5, as it's true. So basically you are now classifying that this car, that Toyota Corona, will have a VS engine. All right. Now, if you were to do that for Ford Pantera L, let me do that for you also. So basically, I'll just have to change the data values. So that is 351 for this. Displacement is 351 and weight is 3.170. All right. So let's predict the value again. Right, so now it says false, right? So you have classified VS as true or false. So true is when it will have a VS engine, and false is when it will not have a VS engine, right? So you regressed to a probability, and based on that probability you classified, and that is the reason you call this particular algorithm, that is logistic algorithm, as a classification algorithm as well as a regression algorithm as well. All right. Does that make it clear to you, Anita? All right. Any more questions, guys? Anything that you want to understand? All right. So Tracy says, nice session. Thank you. Okay. You're welcome, Tracy. Any more questions, guys? And I shall explain it to you again. No worries. I shall explain the whole session to you again. Any doubts? Okay. Since most of you are clear, let me end this session now. Let us wrap up this session. So thank you for attending this session, guys. I hope you guys learned something new today. This code that we have executed today has been uploaded in your LMS, and as well I have uploaded some assignment as well. I want you to solve that assignment and come back in the next session with it. All right. Any question, if you find any difficulty in doing anything, you have our support team which is available for you 24/7. Alright guys, so thank you for attending today's session. I hope you have a great day ahead. Goodbye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!